Okay, so today we have quadratic functions. So again, quadratics are something you've done more than once. The characteristics of a quadratic function, of course, it's not linear. It's of the form y equals ax squared plus bx plus c, where a is not 0. If a were 0, then it wouldn't be a quadratic. It would be a line. This form is called the standard form of a quadratic function. The shape of a quadratic function is called a parabola, and it's a U shape. You can see a picture of one there in the diagram, right side up or upside down. Parabolas are symmetric around a central line called the axis of symmetry. So what that means is that if you find points on one side of your parabola, that you will have those exact same points symmetrically on the opposite side of the parabola, on the opposite side of that axis of symmetry. When you graph a parabola, you do not have to graph the axis of symmetry unless you're told to. If you do graph it, you should be graphing it as a dotted line because it's not actually part of the parabola. The axis of symmetry intersects the parabola at only one point, and that's called the vertex. The vertex is the minimum or the maximum value of the graph. Everything is symmetric from that point on. And then there is always a y-intercept at C. If you plug in 0 for x to find that y-intercept, turns out that it just ends up being the letter C, whatever that number happens to be. But there's not always an x-intercept. If your graph is entirely above the x-axis or entirely below the x-axis, then it doesn't cross the x-axis. So don't be concerned if you don't have one. Now, if your a value is greater than 0, that means that your graph opens up, which would mean that it has a minimum. Essentially, this is what your graph would look like when you graph it. So the vertex there is your low point. If a is less than 0, it opens down, and then that vertex is your maximum. And again, that minimum and maximum always happens at the vertex. Now the x value of the vertex, which is the axis of symmetry, you can find that in two ways. You can use the graphing calculator, and I'll show you how to do that. You go to your calc, go to calc, which is the second trace button, and then use min or max. And you can do it by hand using the formula x equals negative b over 2a. The a and the b happen to be from the equation up here at the top. And once you find that x value, which again is the axis of symmetry, you plug that back into the equation to find the y value, and that's your vertex. Now, again, quadratics can be graphed using symmetry. You have to have the vertex and at least one point on one side, and then you can duplicate that point on the other side. Just to show you over here on this graph, let's say that we figure out what this point is here. That point is 2 away from that axis of symmetry, so I have to have a point 2 away on the other side. The thing about that's helpful is one point that's super easy to find is the y-intercept. If you find that y-intercept, you can see, hey, that's just 1 away, so I'm going to have a point 1 away on the opposite side. Now in this picture, again, these are things that are important to graph. The x-intercepts, the y-intercept, the vertex, that axis of symmetry, again, you don't actually have to graph that on your graph. Okay, so we're going to talk about how to find all these things by hand, and then I'll show you how you would do it in the calculator. So find the vertex, axis of symmetry equation, x-intercept if you have them, and the y-intercept of each function. State whether there is a minimum or maximum. Draw a sketch of the graph. Okay, so let's start off with finding the axis of symmetry and the vertex. So in this case, my a value is -2, my b is -2, and my c is 4. So x equals negative b over 2a. It's really opposite of b over 2a. So since my b is negative, that's going to be positive 2 over 2 times -2, which is going to be a negative 0.5. Be careful putting this into the calculator. If you put 2 divided by 2 times -2, it's going to tell you the answer is -2. You need to put that entire bottom in a parenthesis, or just do it by hand. So x equals negative 0.5. Now to find the y part of that, we're going to plug that back into the original equation. So -2, negative 0.5 squared, minus 2, negative 0.5, plus 4. Type that in your calculator exactly the way that it looks, making sure you have those negative 0.5s in parentheses. And we end up with 4.5. So my vertex is negative 0.5, 4.5. Okay. Now, would that be a minimum or a maximum? Well, when you graph this, your A value there is negative. So what that means is that if I drew a little picture here, the graph's going to go down, which means that that maximum point there, or the vertex, is a maximum point. Okay. Now, y-intercept, let's do that first because that's the easiest. The y-intercept, you're going to plug 0 in for x. So y is equal to negative 2, 0 squared. Okay, you can do that in your head. It just ends up being 4. And again, it really is always that c value. Now the x-intercept, on the other hand, is a little bit more complicated. We want to set it equal to 0. So that's going to be negative 2x squared minus 2x plus 4. Factor out the negative 2. Factor some more. Now, you're going to set those equal to 0. I can't set negative 2 equal to 0, but I can set the other two. And I end up with negative 2 and 1. So, now let's plot these things. My x-intercepts, we've got negative 2, positive 1. Have a y-intercept at positive 4. Okay, now my vertex is going to be a little tricky to graph here because of the decimals. It's going to be really close to my y-intercept, actually. Negative 0.5 up 4.5. So kind of in the middle of that box right there. And then that's it. We're going to draw our equation. Now, I have enough points to make a parabola. I have to have at least 3 points, not all on the same side. So I've got 2 super close ones right here. I didn't mean for that to be that fat of a graph there. That's it. Now, if for some reason I only had 1 point on one side, I would just use symmetry to find the point on the other side. That's a little harder to see on this graph because my vertex is a decimal, but I'll show you that on the next one. Okay, and I'll show you that in the calculator here in just a second. Okay, same process on the next one here. My A value is 1, my B value is negative 6, my C value is 13. So x is equal to opposite of B, 6, over 2 times 1. My axis of symmetry is 3. Okay, find the y part. Y is equal to 3 squared, 6 times 3, plus 13. That ends up giving me 4. So my vertex is 3, 4. Minimum or maximum, this graph has an A value that's positive, so my graph would look like that. So this one's going to have a minimum. The y-intercept, again, that's the easier one, so starting with that, my y-intercept is going to be 0 squared, 6 times 0, plus 13. That's going to be 13. And then the x-intercept, that one we're going to set equal to 0. X squared minus 6x plus 13. This one does not factor. So I have 2 choices. I can use, actually 3 choices. I can use the quadratic formula. I can use the polysimultation 2 app. I don't know what it actually stands for, but the PLYSMLT2 app. Or I can look at the graph and figure it out from the graph. Turns out there is no x-intercepts. If we use the quadratic formula or the app, it's going to tell us no solution, or we're going to have the square root of a negative, which we can't do. When we look at the graph, it doesn't touch the x-axis, so that means no x-intercepts. Okay, so to graph this one now, I'm going to put the vertex in blue here. So we're going to go 3 up 4. Remember, the graph is supposed to go up from here. Now, problem is, the only point that I have to put on here right now is the y-intercept, which is 13. I can't get to 13, so I'm just going to pretend that that's 13 right there. Now, remember our symmetry? That y-intercept is 3 away from the vertex. If I go 3 away over here on this side, I'm going to have another point right here that would also be at 13, and there's my graph. Now, it really would be better to get some other points, which I can get by plugging in other numbers. If I plug in 4 or 5, those are going to give me values that I can plot. And I'll show you how we can do that again on the calculator in a second. If I plug in 4, I end up with 5, which means if I plug in 2, I end up with 5. If I plug in 5, I get 8. And so that means if I plug in 1, I get 8. Okay, and then we can draw our graph here. So there's our graph, there's our graph. Now you really don't want to plot points that don't fit on the grid that you're provided, but I just wanted to show you how you would do that otherwise. Okay. All right, so in the calculator here real quick, let me actually do both of these real quick because I want to show you different things on them. So for the first graph here, we're going to type in negative 2x squared minus 2x plus 4. And actually, I don't, well, we'll look at this. Okay, so we're going to graph. Okay, and that looks like the graph that I did there. Okay, what if we're trying to find the vertex using the calculator? Okay, so to do that, we're going to hit second in the trace button, and we're going to go to minimum or maximum. Well, since this graph is going down, that means it's going to have a maximum, so number 4. Okay, and it's going to ask me 3 questions. Go to the left of where you think your maximum is, hit enter. Go to the right of where you think your maximum is, and hit enter. And then where do you think the maximum is? Now, depending on what kind of calculator you have, you may not have those dotted lines, but you'll have those arrows that face towards each other. Hit enter one more time, and that's my vertex. Okay, so now here's the thing. Negative 0.49999, probably that's negative 0.5, and we know from doing the math that it is. Sometimes there are limitations on the calculator, so you have to take an educated guess. You can check that for real by plugging in negative 0.5 and see if it gives you 4.5, either by hand, or if you go to calculate here and go to calculate value, you can actually type in negative 0.5 and hit enter, and it tells you, yes, that is 4.5. Okay. Now, the other thing I wanted to show you is how to find an intercept. So we're going to go to calculate 0. Okay, the 0 is where the graph is equal to 0. But again, it's going to ask you 3 questions. So go to the left of your intercept, left on the number line. It looks like my intercept is negative 2, so negative 2.3 would be to the left. Okay, and then go to the right, and then go to where you think it is, and hit enter, and there's my intercept. And you would do the same thing on the other side to find the other one. Okay. Now, if we want other points that are on the graph, go to your table. Okay, and those are all numbers that I can plot. All right, now for this question here, they've given me the equation for a parabola right here, and they want me to graph the path of the ball. So again, I could type that into the calculator, no problem. Otherwise, I could use the information that I know to narrow this down here. So if I find out, now all of these graphs go down, so I can't narrow it down that way, but I can find the vertex because they do all have a different vertex. Now I should tell you that, well, I'll tell you that here in a second. So if I do my negative b over 2a, negative b over 2a is negative 8 over 2 times negative 1 gives me an answer of positive 4. So this graph is out, this graph is out. So it's just a matter of, okay, this is 212, and then we'll figure the other one out here in a minute, 412. So it's just a matter of which one of those is going to match with the actual vertex. So I plug 4 in. Turns out that when I plug 4 in, I end up with a vertex of 18. Now, this point here is actually really, this scale is off on this graph. So we're going to pretend that that's 18. This is the graph that they want it to be. Okay. Now, at what height was the ball hit? The ball was hit at time 0. So you're going to plug 0 in for x. So y is equal to negative 0 squared, 8 times 0 plus 2. The answer is 2, so that would be 2 feet. Maximum height of the ball, that's your vertex, so 18 feet. Anytime with a quadratic they ask you to find a minimum or a maximum, it's going to be your vertex. Now, when did the ball hit the ground? That's going to be where it's equal to 0. So you're going to set this equation equal to 0. Now, this equation does not factor. So I've got three choices. Again, I can use the quadratic formula. I can graph it and find that place where it intercepts the same way I showed you a minute ago, or we can use the app to solve it. Now, just since we haven't done that in a while, let me remind you. We go to app, and you're looking for the polysymbol 2, and you want to use the root finder. So number 1, everything on this page will stay the same. Hit next. And then you put your values in. So A is -1, 8, 2, okay, and then hit solve. Now there's two answers there. The negative doesn't make sense, so it would be 8.2 seconds is when it hits the ground. Okay. Now, the last part of this has to do with transformations. Now, that's something that you, again, talked about in Algebra 2 and in Pre-Cal quite a bit. This is our normal graph parent function, f of x equals x squared. And so I can plug numbers into that, and I can get the values of that parent function, the vertex being at 0, 0, and then symmetric points on either side. Now, if you do transformations to this, stretch it, shift it, flip it, that kind of thing, you can change that actual graph. So again, the normal graph would be just x squared. If you put an a value here in the front, that's going to determine if it's stretched vertically. It also will possibly reflect the graph. Think about a being positive means the graph goes up, a being negative means the graph goes down. That's because it does a reflection. H, that's a horizontal translation. Now the thing about the horizontal translation, if it says x minus a number, that means the number goes to the right. If it says x plus a number, that means the number goes to the left. It's actually backwards of what you would think. And then the k is going to be a vertical translation, moving it up or down. So a, h, and k, those are all going to be constants. And you don't have to have them. Of course, you don't have to move the graph up or left or right or whatever. Now, one other thing here, when you do these transformations, and we'll talk more about this later, you have to start off with your horizontal translation. Then, if you have a flip or a vertical stretch or compress, you do that next, and then you do your vertical translation. So you start inside. It's kind of like order of operations. You do inside the parenthesis first, and then you do outside the parenthesis left to right. So what that does is that moves, if you have that transformation h and k, that moves your vertex. Normally your vertex is at 0, 0, but if I shift it right and up, that's going to move my vertex right and up. So for example, let's say that I have an equation here, okay, using the information there in the table above, that's going to make my vertex be 4, -2. I'm moving right 4. Remember I told you that it was kind of opposite. Right 4 and down 2. And you can see over here the new graph reflects that. All right. So a couple little quick examples here. Use the graph f of x equals x squared as a guide. Find the translation, new vertex, and sketch the graph. Okay, so in this case, and I forgot to write all this down on my notes, my translation here is going to be left 1 and up 3. If I move my vertex left 1 and up 3, that's going to be a new vertex of -1, 3. Now, if you can't visualize that, you can draw the original one and then move it. So the original graph, using the points that are up above there, would look like this. Okay. Well, I'm going to take every one of those points and move them left 1 and up 3. So top point, left 1, up 3. Well, I can't actually really see that one, so let's go down lower. Left 1, up 3. Left 1, up 1, 2, 3. Left 1, up 1, 2, 3. And then again, that top point I can't see. So we can only see those bottom 3 points because the top ones are too far up. That's my new graph. And we see there verified that my vertex is -1, 3. Now this last one here, this graph is going to go down 2. So again, here's my normal graph, 2, 4, and you don't have to memorize this graph because you can get that just by plotting points in. Graph the new one now, everything's going to go down 2. Oops. I missed the point there, but you get the idea. Now, of course, you can type those into your calculator to get a graph if you need to, but it is something that I think at least you should know how to do by hand as well. Okay, now, vertical stretch or reflection. So basically what happens here is if you have a negative that you put out in front, it's going to flip your graph over the x-axis. It's going to flip it vertically. And you can do that change by taking all of your y values times the negative. So x, y, if I flip that, it becomes x, negative y. A vertical stretch or compress, you're going to multiply your y values times that number. If the number is greater than 1, it's going to stretch it. If it's less than 1, it's going to compress it. So this is going to take your point xy and make it be x, ay, and a is going to be whatever that stretch or compress is. Now we're going to kind of combine those here in the next example. Take that normal graph and let's do g of x equals negative 3x squared. Okay, well that negative is going to reflect you vertically. The 3 is going to stretch you vertically because it's greater than 1. So what I can do here is I can take all of my points and I can make them be x, negative 3y. Okay, so we are going to take all those normal points here, here and here and here, here and here. And you can actually write them out if that's helpful. And I'm going to take all the y values times a negative 3. Now that's not going to fit on the graph. This one will. This one doesn't change because you multiplied 0. Now, like I said, these bottom two, to the top and bottom ones aren't going to fit on my graph, but the other ones I can. We're going to do negative 1, negative 3, and positive 1, negative 3. 0, 0 is still in the same place. Now, we'll just kind of fake the other ones here, okay, just so maybe you can see that the graph has been stretched. When you stretch a graph vertically, and I did a horrible job of connecting those points, but when you stretch a graph vertically, what happens is the graph looks skinnier than what it does before. If you compress a graph, you're pushing down on it, and it actually makes it look fatter. Okay, 2 more parts here. The next one here, we're going to write an equation and sketch the graph. Now, when you write the equation, your horizontal is going to go in the middle, your up or down is going to go on the outside, your compression is going to go on the outside. So I'm going to color code this here a little bit. We're going to compress vertically. We're going to translate to the right, and we're going to go down. So when I write this equation, what this is going to look like here, I'm going to write it underneath my graph here. 1/2 x minus 2, because we're going to the right and it's opposite of what you would think, and sorry, not plus 4, minus 4. Okay, so that's my equation. So to do that now, I told you earlier, you have to do this first, and then we're going to do this one second, and then we're going to do this one third. It's order of operations. Do the inside the parenthesis first, and then left to right. So if we take those normal points, and I'm going to put the normal points just in black here, skinnier black here. Those normal points were negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Now, when I do my translation to the right, you can do it on the graph, but if you move the points to the right, you're actually adding 2 to the points. So next, I'm going to have 0, 4, add 2, 1, 1, 2, 0, 3, 1, 4, 4. Okay. Next, compress by 1/2. So that means that I'm going to take all of my y values times 1/2. So that's going to be 0, 2, 1/2, 2, 0, 3/2, 4, 2. Okay, now move down 2. I'm going to subtract 2 from all of my y values. I'm sorry, subtract 4. We're moving down. So we're moving down 4. So subtract 4. Minus 2. 1, negative 3.5. And I don't care if you do a decimal, that's fine. 3, negative 3.5, and 4, negative 2. Now, I'm going to put the original graph here in black. So that was 0, 1, 2, 4. Okay. My new graph, I'm just going to do the final graph in red. Over 0, negative 2, 1, 3.5, 2, negative 4, 3, negative 3.5. And remember, you should have symmetry as you do this graph. Okay, there's my new vertex, and there we go. All right, last one here. Find the x and y intercept of the following. Okay, so sometimes on this type of question, people think that they have to actually do the squaring and get rid of the parentheses and whatnot, and it's actually really harder to do that. Let's start off with the y-intercept. That's the one that's the easiest. Just like before, you're going to plug 0 in for x. So y is equal to negative 2, 0 minus 3 squared plus 8. So that's going to be negative 2. Negative 3 squared is a positive 9. Okay, just do it by hand. If you do it with a calculator, sometimes you forget to put it in a parenthesis and you end up getting the wrong answer. That's going to be y equals negative 10. Now, x-intercept's a little bit more complicated, but again, still easier than trying to multiply through everything. Okay, set it equal to 0. Solve for x. So first, let's try to get that x by itself. So subtract 8. Okay, then divide by negative 2. Okay, now take the square root of both sides, and when you do that, you have to do a positive and negative. So I have 2 is x minus 3, and I have negative 2 is x minus 3. I didn't really need to have those in parentheses anymore. Add 3 to both of these, and those are my 2 x-intercepts. Now, again, you could find that by graphing it, but you really shouldn't necessarily need to do that. Now, let me show you, though, real quick how you could find these in the calculator and maybe just verify it. Okay, if you type this equation in here, you're going to have negative 2 parenthesis x minus 3 squared plus 8. Always double check that you've typed things in your calculator correctly before you graph them. Okay, so my y-intercept was negative 10, which I can't quite see for sure that that's what that is. If I change my window and make it go down a little bit lower, this one's only going down to negative 10 on the y. What if we make it go down to, say, negative 15? That'll be plenty of space. Graph it. And yeah, we can see that. Now, it looks to me like my y-intercepts, or my x-intercepts, are at 1 and 5. I can check that 2 ways. I can go to calculate again and calculate value. I can plug in 1, and it tells me it's 0. I can plug in 5, and it tells me that it's 0. I can plug in 0 if I want to find that y-intercept, and I can see that it's negative 10. Or I can look at my table. So when you look at the table, you can see you're looking for x-intercepts. Where is my x equal to 0? So I can see 1 right here. Sorry, it won't let me write on it again. 1, 0. You can see that. So 1 is an x-intercept because it has a y value of 0. Here you can see the y-intercept. It's where the x is equal to 0. And if you scroll up to the negative 10, you can see that that y-intercept is there too. I'm sorry, we already saw the y-intercept. If we, oh, they're all in here. Here's the one x-intercept, here's the other x-intercept, here's the y-intercept. Okay, so the calculator can be used to back things up. Don't just rely that, oh, I'm just going to do everything in the calculator, because there could be questions worded in a way that you have to know. Like, they're not going to give you an equation you can graph. You have to know how you would find the vertex. You have to know about the symmetry that is used. You have to know about the transformations. So do make sure you do as much of this as you can with the calculator, or I'm sorry, without the calculator, but just use the calculator to back things up.